Here's integrated 3. It's 10-189. It says, given the points 0, 0, and negative 5, 12, what is the equation of the circle centered at point O and passing through point R? So I took my two ordered pairs, and 0, 0, of course, is here, and then negative 5, negative 12. And then I realized that's the radius of a circle right there. It's going to be a circle that goes around. And I know that the equation of a circle is x squared plus y squared equals r squared. So I need to find out the length of r. And so that 13, I don't know that yet. I know that this negative 5, I know this side of if I draw a triangle, this side's 5, and this is 12, but then I can use Pythagorean theorem, like 5 squared plus 12 squared equals c squared. (169) equals c squared. So c is going to be 13. So square root of 169 is 13. So that's where that 13 came from. So now I have that, and then letter B says, what is the measure of the angle formed by OR and the positive x-axis? Answer in both radians and degrees. So now I need this angle. So from here to here is 180 degrees. And then from here to here is some degree angle measure. And I can just use this little right triangle and my calculator. Where did it go? Can use my calculator and I can figure it out. So I know that tangent is opposite over adjacent. So I can say that the tangent of theta is 12 over 5. Tangent of theta, that's the equal sign. 12 over 5. And so if I just inverse tangent both sides, so if I inverse tangent this and inverse tangent this, I'll get that theta is the inverse tangent of 12/5. Oops. And if I'm in degree mode, that gives me this, 67.38. But they want it measured from the positive x-axis. So I'm going to have to add 180 plus this 67 right here, or yeah, 67-ish. So that gives me, that's my degree measure right there. Now, I have to do the whole thing over. I just did the whole thing over in radians. Like, I put my calculator in radian mode, and instead of converting these, I just did the problem again, because it's just inverse tangent of 12/5. So that's not too hard to do. Inverse tangent of 12. Okay, so I get that, but that's how many radians this little part is, and then I have to add to it pi radians, because halfway around the circle is pi radians, so I'm going to go plus pi, and that's where the 4.32 comes from. So that's how you do that part. And then letter C says, graph your circle and graph this other circle on the same set of axes. So our circle had a radius of 13. So I think I've already counted these. I think that's 13, 13, 13, 13. Don't make fun of my circle. It's going to look very non-circular, probably. There's my circle. Sorry about that. And then it wants me to, with that circle on the same set of axes, it wants me to put another circle, x squared plus y squared equals 144. So that must have a radius of whatever the square root of 144 is, which is 12. So this one's 12, 12, 12, 12. Oh my goodness. There we go. And then it asks me in letter D, oh, letter C or D, I don't know, letter D, if we use these circles as a dartboard and the dart is certain to hit randomly somewhere within the largest circle, what is the probability of hitting the shaded region? So the shaded region is between the circles. And I think this is letter D. The picture was letter C. So probability is favorable over total. Favorable over total. That's how I always say it. So favorable would be anywhere in the shaded part, and total would be anywhere, inside the larger circle. So the area of this shaded part is the large circle's area, take away the smaller circles. That's why I wrote large minus small. So we know with circles, areas are pi r squared, but I can get rid of my pi because they all have, like I could factor this pi out and then cancel pi's. So basically I can just use the r squared parts of my circle. So this is the large circle minus the small circle. So this will be 169 minus 144 all over 169. That gives me 25 over 169, and that ends up being 0.15. Yep. So is that it? And that is it.